When we calculate the work done by a variable force, we must calculate the area under the force versus displacement graph. To be more precise, we must calculate the area under the graph of F cosine theta versus S, where F is the magnitude of the force, S is the magnitude of the displacement, and theta is the angle between the force and the displacement. The figure shows the force versus displacement graph for a high-tech compound bow used by archers. The maximum force is 180 newtons, and this corresponds to 20 units on the vertical axis. So each unit on the vertical axis is 9 newtons. The maximum displacement is 0.500 meters, and this corresponds to 18 units on the horizontal axis. So each unit on the horizontal axis is 0.500 meters divided by 18, which is 2.78 times 10 to the minus 2 meters. To get the area under the curve, we would count the 242 small squares under the curve. Then we would use the fact that each square has an area of 9.00 newtons times 2.78 times 10 to the minus 2 meters, which is 0.250 joules. But counting squares is tedious, and we often need a quick way to estimate the area under the force versus displacement graph. So, we will look at a way to use geometry to estimate the area. In the figure, triangle A is a right triangle, and we can use its area to estimate part of the area under the curve. We can easily calculate the area of triangle A, but we must keep in mind that newtons are the units on the vertical axis of the graph and meters are the units on the horizontal axis. We now look at triangle A. This is a right triangle with a base of 0.250 meters and a height of 180 newtons. The area of a triangle is 1/2 its base times its height. So, the area of triangle A is 1/2 times 0.25 meters times 180 newtons. Since force in newtons times distance in meters gives work in joules, the area is 22.5 joules. Now that we have the general idea, we will divide the rest of the area under the curve into one triangle, which we will call B, and two rectangles, which we will call C and D. The figure now shows the two triangles and the two rectangles. Now we will look at triangle B. This is another right triangle. It has a base of 0.195 meters and a height of 72.0 newtons. The area of this triangle is, again, 1/2 its base times its height, and the area will be in joules. So, the area of triangle B is 1/2 times 0.195 meters times 72.0 newtons, which is 7.02 joules. Now let's look at rectangle C. It has a base of 0.0556 meters and a height of 180 newtons. The area of a rectangle is its base times its height, and the area of this rectangle will be in joules. So the area of rectangle C is 0.0556 meters times 180 newtons, which is 10.0 joules. Now we look at rectangle D. It has a base of 0.195 meters and a height of 108 newtons. Its area is its base times its height, and that area will be in joules. So, the area of rectangle D is 0.195 meters times 108 newtons, which is 21.1 joules. This table summarizes our calculations. Now we can add up all the areas and get the total area, which is the area under the curve. The total is also the work that was done when the bow was stretched, and we get a value of 60.6 joules. The area of all the small squares, both red and white, in the figure is 180 newtons times 0.500 meters, which is 90.0 joules. Using this fact, how could you calculate the area under the curve using the areas of the two white sections of the figure? Hint: approximate each white section by a triangle.